Hello, today we're going to look at the conservation of momentum. So in a closed system, the total momentum before a collision is equal to the total momentum after the collision. So let's take a look at an example so we can see what this might mean. So we've got an example here where a dog of mass 30 kilograms jumps off from a stationary skateboard of mass 0.5 kilograms. The skateboard moves backwards at 2 meters per second. How fast does the dog move and in what direction? I tend to always draw a diagram of what happens before and then afterwards. So I'll split it into two columns. On the left-hand side, I'll write before, put a dotted line in the middle, and on the right-hand side, I will then write after. So before, I'll then draw a diagram. So here we've got a ball, or a dog in this case, on a skateboard. And then let's find out the key things. So let's just go through. So we know the mass of the dog is 30 kilograms and the skateboard 0.5 kilograms. Now they're one unit, so they have a total mass. If they were separate, we'd treat it separately, but because they're one unit, we know the total mass is 30.5 kilograms. Then we need to think about the velocity, because momentum is mass times velocity, and in this case it's stationary, so it's 0 meters per second. So then we can find the total momentum before the collision, so mass times velocity, but that's then just 30.5 multiplied by 0, which of course will give us a 0 kilogram meter per second. So the total momentum before the collision is 0. And now that means, because of the conservation of momentum, that the momentum after the collision has to also equal 0 kilograms meters per second. So we carry that forward onto the next part. Let's redraw what's happened because we've changed. We've now split up. The skateboard has moved backwards. That's still 0.5 kilograms. The dog is still 30 kilograms. And now let's add our velocities. So that's then 2 meters per second. Now backwards, we tend to put a minus sign on there. We'll see that in a moment. So let's find out the momentum of the skateboard. So then that's 0.5 multiplied by minus 2, which then gives us minus 1 kilogram meters per second. So the minus means left. Now the momentum after we said was 0, so let's remind ourselves. So that means the momentum has to add up to 0. So we know it's backwards is minus 1, so forwards has got to be 1, because minus 1 add 1 gives us our 0. The total momentum has to add up to 0. So then we can rearrange the equation for velocity. So that's momentum divided by mass. We know the momentum of the dog has to be positive 1. The mass is 30 kilograms. So therefore, the dog will move with a positive velocity of 0.03, and that means it's going to be to the right. So a negative velocity tends to be to the left, a positive one tends to be to the right. So let's look at a second example where we've got two separate objects. So we turn the words into a diagram, so we pick out the key things. So here I'm saying the mass of the first object is 10 kilograms and the second is 5 kilograms. The velocity, picking it out from the question, would be say 5 meters per second, and the second object is stationary, so 0 meters per second. So that's before. And then after the collision, the question will tell us that they've joined together or they've stuck together, so we've got a new mass. Well, if they've joined, you just need to add the two together, so that's 15 kilograms, 10 plus 5, and we want to find the velocity. So we start by looking at the momentum of each of the different balls. So the first one is 10 times 5, so 50 kilogram meters per second, and the second one is 5 times 0, which of course gives us a 0 momentum for the second object. But we still need to find the total momentum before the collision or the episode. So the total momentum, we add them together, so that's then 50 plus 0, so the total momentum before is 50 kilograms meters per second. Then we need to remember that before is the same as after, so the total momentum after the collision has to be the same, so that's also 50 kilogram meters per second, and we want to find the final velocity. So we can use the equation, mass times velocity, rearrange it for velocity, so that's momentum divided by mass. We use the same momentum as we just calculated, so 50 divided by the mass of the object stuck together, and then in a calculator that gives 3.3 meters per second. Now it's a positive value, so that means it moves to the right. If it had been a negative number, we would say that's the opposite direction to what it started, so we'd assume that would be left.